Hi students, today we are going to learn the lesson Force and Motion. As shown in the above picture, Kavita can reach her school in two ways. Can you tell by choosing which path she could reach the school early? She select road A. Look at the nearby picture. In which path the leaf will reach the ground first? Path A. From the above example, we could conclude that the straight line path is the shortest distance between the 2 points. Distance, the total length of the path taken by an object to reach one place from the other is called distance. What is displacement? The shortest distance from the initial to the final position of an object. Both the distance and displacement possess the same unit. The SI unit is meter. See this picture. The path of an object traveling from A to B is shown in the figure. Total distance traveled by the object is 120 meter. The displacement of the object is 40 meter. Next topic is speed. In 6th standard, we already studied about speed in detail. Speed is the rate of change of distance. Speed is equal to distance by time. Unit is meter per second. We can classify speed into two types. One is uniform speed. If a body in motion covers equal distance in equal intervals of time, then the body is said to be in uniform speed. What is non-uniform speed? If your body covers unequal distance in equal interval of time, the body is said to be in non-uniform speed. How can we calculate the average speed? Average speed is equal to total distance travelled by time taken to travel the distance. Move on, velocity. What is velocity? Velocity is the rate of change in displacement. Velocity V is equal to displacement by time. SI unit of velocity is meter per second. Here see the picture. If an athlete in the diagram takes 25 seconds to complete a 200 meter sprint event, find her speed and velocity. How can we calculate speed? That formula is distance by time. Here distance is 200 meter, second 25 seconds. So 200 divided by 25 is equal to 8 meter per second. So the athlete's speed is 8 meter per second. What is her velocity? Velocity is equal to displacement by time. So 50 divided by 25 is equal to 2 meter per second. Uniform velocity. A body has uniform velocity if it covers equal displacement in the same direction in equal interval of time. Example, light travels through vacuum. Non-uniform velocity. If either speed or direction changes, the velocity is non-uniform. Example, a train starting and moving out of the station. How can we calculate average velocity? Average velocity is equal to total displacement by time taken. See this diagram. The triangle method can help you to recall the relationship between the velocity V, displacement d and time t. V is equal to d by t. T is equal to d by v. D is equal to v into t. Move on, acceleration. What is acceleration? Acceleration is the rate of change in velocity. In other words, if your body changes its speed or direction, then it is said to be accelerated. Acceleration is equal to change in velocity by time. V minus u divided by t. Here, acceleration is equal to change in velocity by time. V is equal to final velocity U is equal to initial velocity, T is equal to time. Positive acceleration. If the velocity of an object increases with respect to time, then the object is said to be in positive acceleration or just acceleration. Negative acceleration. If the velocity of an object decreases with respect to time, then the object is said to be in negative acceleration. Uniform acceleration. An object undergoes uniform acceleration when the change in its velocity for every unit of time is the same. Non-uniform acceleration. An object undergoes non-uniform acceleration if the changes in its velocity for every unit of time is not the same. Move on. Center of gravity. Try to balance a cardboard on your fingertip. What do you observe? We observe there is only one point which is the cardboard is balanced. That point is called the center of gravity of the cardboard. The center of gravity of an object is the point through which the entire weight of the object appears to act. How do we find the center of gravity of an object? See this diagram, center of gravity for regular shaped objects. Generally, the center of gravity of the geometrical shaped objects lie on the geometric center of the object. Examples: weight of card, weight of triangle, weight of disc, weight of ring. Next one is meter rule. The ruler is an equilibrium when supported at its center of gravity. For a regular object such as uniform meter rule, the center of gravity is at the center of the object. When the object is supported at that point, it will be balanced. If it is supported at any other point, it will topple. Stability. What is stability? Stability is a measure of the body's ability to maintain its original position. There are three types of stabilities. One is stable equilibrium. Second one is unstable equilibrium. Third one is neutral equilibrium. Stable equilibrium. The frustum can be tilted through quite a big angle without toppling. Its center of gravity is raised when it is displaced. The vertical line through its center of the gravity still falls within its base, so it can return to its original position. Unstable equilibrium. The frustum will topple with the slightest tilting. Its center of gravity is lowered when it is displaced. The vertical line through its center of gravity falls outside its base. Neutral equilibrium. It causes frustum to topple. The frustum will rolls about but does not topple. Its center of gravity remains at the same height when it is displaced. The body will stay in any position to which it has been displaced. Conditions for stability. To make a body more stable, lower its center of gravity. Second point, increase the point of its base. Third one, this box is at the point of tipping over. Fourth one, a heavy base lowers at the center of gravity so the box does not tip over. Fifth point, a broad base makes the box more difficult to tip over. The Tanjavur doll. It is a type of traditional Indian toy made of terracotta material. The center of gravity and the total weight of the doll is concentrated at its bottom most point, generating a dance-like continuous movements with slow acceleration. Real-life applications of center of gravity. It is for the reason of stability that the language compartment of the tour bus is located at the bottom and not real-life applications of center of gravity. It is for the reasons of stability that the luggage compartment of the tour bus is located at the bottom and not on the roof. Extra passengers are not allowed on the upper deck of the crowded double-decker bus. Racing cars are built low and broad for stability. Table lamps and fans are designed with large heavy bases to make them stable. Today's homework is read the 5 short answers. Thank you.